Stick around.
Today we'll be doing BountyHunter, which was an easy Linux machine from Hackthebox. On the website, we discover a form that submits bug bounty data to a server on the backend using XML. We then use an XML External Entity Attack to leak information from the server, which gives us a foothold on the box. And once on the box, we discover that we can run a specific Python script as sudo. So by crafting a payload that's read by the script, we can use the eval function to spawn a new bash shell and get root on the box. So let's get to it.
Napoleon, like anyone can even know that.
To start off, I'll run an nmap on all ports, and we can see that we have port 22 SSH as well as port 80 HTTP. So I'm going to rerun nmap. This time I'll specify the ports 22 and 80 since we know that's what's open. As well, I'll tack on to enumerate for standard versions as well as run standard scripts.
A few minutes later.
And we can see port 22 is running OpenSSH on an Ubuntu server, and we can see on port 80 we have an Apache web server. Not much else that's of use for us right now, so let's go check out the website. The website seems to be a mock-up page for bug bounty hunters. Most of the links are broken and the contact form is inactive. So let's check out the portal page here on the top right. We can see a message. Let's click the link. And we can see a system where we can report bugs. Let's just fill this in with random information and see what the result is. And we can see it's reflecting the information back to us. Let's intercept the request and see what's happening on the back end. First, activate your proxy, then open BURP. And in BURP, we can turn on Intercept. Now back on the website, let's resubmit. And we can see the BURP was able to intercept the request. Let's send it over to Repeater. And here in Repeater, we can immediately see something interesting. Right at the bottom of the request body, we can see the data is encrypted. However, we can simply highlight it and it will be decrypted right here in BURP. And then we can observe here that the web application utilizes XML to transmit form data from the client side to the server through an HTTP request. So whenever we see this case of XML being used in this manner, we can immediately try and see if perhaps we can do some XML injection, also known as an XML External Entity Attack. Let's head over to Hackthebox. So here on Hackthebox, I'm on the page for XML External Entity Attack, and we can go down and navigate to the section header read file. So basically we're going to use this command to try to see if we can leak some information from the server. This is very similar to an LFI. And here we can see the command. Let's simply integrate this back into BURP. Here back in BURP, you can see I've added the attack. Let's hit apply changes. We can see that the encrypted data changed. Let's send it over. And we can see immediately that we're able to leak the XXE password file. And we can go down and we can see of interest to us here is a user ID 1000 development. Great, so now that we have a username and we also have the ability to read files from the target system, let's see if we're able to find other credentials such as a password or a hashed password. So whenever we have any form of LFI, there's always three things I like to go for. The first thing would be the XXE password file, obviously useful because this tells us the name of the user on the box. Also, we can look for any specific config files, especially related to databases. And the third thing is I simply like to look at the backend code for the web server pages. So let's do that now. But since we haven't really fully enumerated all the pages present on the web server, I'm going to run Gobuster. So here back in the terminal, let's run Gobuster. We'll enumerate for directories. We'll specify the URL. After that, we'll specify our word list. And finally, also I'll tack on to enumerate for PHP pages. And here are our results. We can see three interesting PHP pages of interest: DB, index, and portal. Well, since index is more than likely the page we landed on initially, and portal is more than likely the page we submitted the form from, let's go and check out DB, which usually means database, which is of course of interest to us because it signifies that there might be credentials in that page. So let's head back to BURP to see if we can leak the contents of the DB page. However, first let's head over back to Hackthebox. And here back on Hackthebox, if we just scroll down a little bit, we can see that if the web server is running PHP, we need to slightly adapt our command. So we'll simply add this part. So here back in BURP, we've added the PHP filter, but before we submit this, we can see that we're still requesting the XXE password file. Of course, what we're interested in here is the db.php file, so it might take a bit of back and forth to find out exactly where it is. However, on a Ubuntu Linux, it's typically stored in var html, so that would be the first place we can try. So let's change the directory to that. And now let's apply changes. And let's resend the request. And we can immediately see in the response body that we have encrypted data. So once again, we can simply highlight that right here in BURP. And it has the name of a server, a name, a username, as well as a password. So these credentials clearly seem to indicate that this must be for a database, perhaps a SQL database. However, since we know password reuse is a common problem, let's see if we can combine this password with the known user on the box, which is development, and see if perhaps we can log into SSH using these credentials. And we can see that we're able to log in. Let's see if we can read the user flag, and we can read the user flag.
Nice.
So since we actually have this user password, let's see if we can run sudo. And so here we can see something potentially promising. We can see that we are indeed allowed to run one specific Python script as root. So let's have a look at the script. Basically, it's a very simple script that's meant to validate a ticket file. We can see here are three main functions: load file, evaluate, and main. So let's have a quick look at the script, starting with main. We can see in the bottom the script first calls main, which then prompts the user to enter a file name. That file is then immediately sent to the load file function. Well, the load file function just checks whether or not the file is in the .md format. If it is, we will continue, and if it is not, it'll exit with a message. After the file's format was validated, it is then sent to the evaluate function. Now here in the evaluate functions where things really get interesting, and basically we'll perform a number of checks in order to validate whether or not the contents of the file are correct. So let's quickly run through each line of the evaluate function. We initialize the code line variable as none. This variable will store the line number containing the ticket code. After that, it uses a for loop to iterate through the lines of the ticket file, with I representing the line number and X representing the line content. Then we check whether or not it is indeed the first line of the file. Then we validate that the first line starts with #Skytrain Incorporated. If it doesn't, we'll return false, and if it does, we'll continue. Then we check to see whether it is the second line of the file. We validate that that second line starts with #ticket2. We'll return false if it doesn't, and if it does, we'll extract and print the destination from the second line, and then continue. We'll then check to see if the current line starts with ticket code. We'll store the line number containing the ticket code, and then we'll skip the rest of the loop iteration. Then we use an if statement to check whether or not the code line variable is set, and if the current line number matches it. Then we validate that the ticket code line starts with ***. If it doesn't, we'll return false, and if it does, we'll extract the ticket code by removing the *** and splitting the line at the plus character. Then we'll validate the ticket code by seeing whether or not once we convert it to an integer and divide it by 7, the remainder is 4. Then here is really the most important line in the entire script for us. In this line, it calculates the validation number by evaluating the line after removing the ***. And this is really the key to getting root on the box, specifically the eval function. So let's just talk about the eval function for 1 second. The eval function is a built-in function that can be used to evaluate a string as a Python expression. In other words, we can use eval to run commands on the system, such as spawning a new bash shell. So since we can't manipulate the ticket validator directly, what we basically need to do in this situation is craft a ticket that will be validated as being authentic by the system all the way up until we get to the eval function, and then simply include in our ticket a command that will spawn a new bash shell. So we'll create a ticket file and remember that it has to have a .md extension. So we'll add the first required line, then we'll add the second required line, then we'll add the third required line, and now the fourth and final line where the magic will happen. We just need to make sure it starts with ***, and here we can enter any number which after being divided by 7 will have a remainder of 4, so we can just write 11 and then a plus because we know that it's going to split the line at the plus character, and everything after that will be evaluated by the eval function, meaning right now that the last thing we need to do is to provide it with a Python command that will spawn a new bash shell. And now the last thing for us to do is simply to run the sudo command. So to make this simple, let's just copy and paste this command exactly as it is here, and it asks us for the path to the file, and we can see that we are root. That's it, friends. If you enjoyed my walkthrough, please consider leaking the file contents of the like button or elevating your privileges by hitting subscribe. Until next time.
Peace out.